My experiment was to study the feasibility of placing a micro hydro generator on our property in the Great Smoky Mountains of Tennessee. In this sketch, you can see that all it requires is the right location to produce clean, renewable energy by hydropower. Catch it, pipe it, spin it, and wire it. The technology is available to build micro hydro generators to provide power for a single home. All it takes is the proper conditions present to produce clean, renewable energy. My home is situated in Tennessee near the edge of the Great Smoky Mountains National Park. We have a stream that runs through the center of a 10-acre property and drops in elevation along its way, creating some very beautiful waterfalls. Our mountainside is at a higher elevation than the surrounding areas, such as Knoxville, located 20 miles to our west. Our home is on the northwest slope of a bowl-shaped ridge. The prevailing winds and weather come in from the west and the northwest. Our mountain ridge's top elevation is 2,050 feet, while Knoxville's is only 950 feet. The main ideas that I researched and wanted to explore in my experiment were: first, did our stream and elevation change provide a viable hydroelectric power source with current technology? Hydroelectric power requires water flow and change in elevation to produce power. These factors will need to be measured in my experiment to predict power production possibilities. Second, I hypothesized that our mountainside was a microclimate that is significantly different than the surrounding areas. Historical rain data is available for Knoxville for many years, but my hypothesis was that we would likely receive more rain than the surrounding areas due to orographic life, a concept we learned about in our Earth Science course this year. The equipment I utilized to take measurements are shown on the screen here. Some include a 5-gallon bucket, a weather system, and my trusty rain boots. I was able to get comparison data from Knoxville and various weather stations from weatherunderground.com. I was also able to get 10 years of historical data for Knoxville from this and other websites. I made daily measurements of water flow in our stream at 2 locations for the entire period. I graphed the gallons per minute stream flow data at the top conduit and also at the collection point at the top of the waterfall. I also made daily rainfall and temperature measurements, as well as collecting daily measurements from other weather stations and the official Knoxville station at the airport. I used manual, digital, and mapping methods to measure elevation distance changes along the route of our stream. During the measurements, I discovered significant data accuracy errors with digital measurement techniques. After collecting the data, I was able to first calculate possible power production at our site, including various variables and also variables and equipment that might be used for actual power production. This calculation is based on the simple formula of head times flow divided by 12 equals power. Hydropower specialists recommend using a variable factor from 8 to 14 to compensate for various efficiency and loss parameters in the system. Thus, the formula head times flow divided by 12 equals power. 12 would be a very conservative adjustment factor. To calculate daily power, the formula is power times 24 hours divided by 1,000 equals kilowatt hours per day. With my data collected, I was able to estimate power production from a possible micro hydro generator on our site. The data shows electrical generation of up to 34 kilowatt hour a day, an amount that could run all electrical loads in our home except air conditioning or heat. I was able to confirm with my data the existence of a microclimate in our area. Our rainfall amounts are significantly higher than surrounding areas. Our temperatures are consistently lower. This allows me to adjust historical rainfall data available to show that rainfall is consistent and it amounts to allow power production at reliable levels, over time bearing severe drop periods which have occurred very rarely over the last 10 years. I was very pleased with the results of my project. I learned about the amazing possibilities of hydroelectric power, a clean, renewable energy source. I was able to evaluate the factors necessary at our home to validate the feasibility of a small-scale micro-hydro generator system to replace a significant part of our current electricity usage. This type of study could be done at numerous places all over the country. This could reduce the use of less clean energy alternatives, reducing our carbon footprint, emissions, pollution, and ultimately help in our attempts to reduce global warming.